Welcome, everybody. Thank you very much for coming today. To start with, Dr. Oliver Wilson, examining the resilience of Brazil's Araucaria forest to climate change from 21,000 years ago to the 21st century. He has been developing ways to bring together indigenous and scientific knowledge together to improve our understanding of past, present, and future relationships between plants, people, and climate change. Today, his talk will cover his ongoing work to partner with indigenous communities in Brazil to co-develop an integrated indigenous and scientific understanding of how humans helped shape the country's Araucaria forest over the last 2,000 years. Interestingly enough, the name Araucaria comes from the province of Arauco in the south of a beautiful country named Chile. I leave it up to you.
All right. Hi, everyone. As Juan said, my name is Ollie. For those of you who don't know me, I'm actually married to Hannah. Now, I say that just so you know that if you want to complain about this talk, either don't complain to her or know that she'll have many more complaints to add on to anything to start with. Okay. Now, I am going to talk quite a lot about Araucaria forests in Brazil and around the world, but I wanted to start off with a little introduction to who I am and what I'm doing at the moment. Because that then sort of builds out into the questions of how I got to be doing what I'm doing and why, and then what I'm hoping to do moving forward from that. So as Juan said, I'm a knowledge exchange fellow at the University of York, and in my experience, people don't really understand what knowledge exchange fellows are. Research fellows seem to be kind of bread and butter for universities. Teaching fellows seem to be fairly self-explanatory, and I think I'm one of only a couple of knowledge exchange fellows in the entire University of York, and people just don't know what it is that I do. So I've taken to explaining to people that my job is to help scientists talk to normal people about research, and in particular about research to do with pollen, for reasons that will become clear, hopefully, in a minute. So my knowledge exchange fellowship is all about 3D pollen, and that's because pollen is amazing. Now, can I just have a very quick show of hands who disagrees straight away that pollen is amazing and good and nice and wonderful? Yes, yes, yes. It's a fairly safe bet. There's always going to be a few people who start off being quite unhappy about pollen as a topic. Hay fever affects probably hundreds of millions of people around the world, maybe as many as 30% of the global population. It's a big, big deal. But pollen is important for lots of things. It's very important in nature and in science. I haven't got time to explain all the different ways. That's a whole other talk. But usually people get to engage with pollen through pretty pictures, things like this. This is from a fairly famous book called Pollen, The Hidden Sexuality of Flowers. But generally, this is not a very easy way to engage people with pollen and pollen science. It's just a flat picture, as colourful and pretty as it might be. That's all it is. I think that if you make 3D printed pollen models, you can bridge the gap. And to show you that, I have brought some, well, I brought some, Katerina's brought some. I'm going to say, to illustrate this, really there to play with and keep you happy during my talk. So, take one, pass them on. What you can do when you have 3D printed models of pollen is, well, all sorts. It opens up huge new avenues for conversations with people about science, about pollen, about life, about the way they interact with all these different things. You can put them in museum exhibitions, you can take them to schools or pubs, you can make fairy lights out of them. They appeared on the BBC once, which was a surprise to me. No one told me that was going to happen. And if you're feeling very adventurous, you can even dress up like a bee and walk around Dundee Botanic Gardens holding them as a way of communicating science. But these 3D pollen models are really quite helpful ways of sparking and starting these conversations with people about scientific research. So can you just hold your red one up for everyone to see? So the reaction I tend to get with this red one here is people look at it and go, no wonder that makes me sneeze. Look how spiky it is. Yeah, but in reality, it's spiky so it will attach onto insects. Those pollen grains don't really get released in huge quantities. They don't float very well. That's not a very significant cause of hay fever. But if you just hold up that big white one at the back, that one, that comes from a pine tree. Okay, it looks a bit like Mickey Mouse, and if it was Mickey Mouse, those two ears are sort of flotation sacs, like sails. Okay, pine trees produce pollen in enormous quantities. It can float miles up in the air. It floats for hundreds of miles around. That is the stuff that will make you sneeze. Okay, and so having these 3D models and gives you the opportunity to speak to people in different ways about pollen and the science attached to it. And so there was a strange day a few years back when I ended up in The Guardian about this. If you want to read more, there's a website and a paper I published about the project. But it's I've got to thinking, what more can you do? Not just to talk to people about research, but where else could you go? And so that's sort of the fundamental part of the Knowledge Exchange Fellowship. I'm currently 2/3 of the way through. Part of the project is about making more models or making more files of these models that represent a broader range of the world's plants and pollen, so that more people can find ones that are relevant for them. That's a dandelion. That big white one was a pine tree. That's a grass pollen grain. But then this one, the blue one here, which is my favorite, comes from a tree in Patagonia. This is Canelo. It's not something that people would have come across generally here, but if you're working in southern Chile, southern Argentina, this will be a species you recognize. My aim is so that people will be able to find ones that work for them more or less wherever they're from. But in the rest of this talk, I want to focus in particular on this aspect of the project, which links in with previous work I've done on Brazil. And I hope it's going to try and explain a little bit about how I got to this point, how I came to be doing this project, why I care about doing 3D pollen and engaging people with pollen-related research, and then where further could we take this work with 3D pollen. And then hopefully by the end, you will understand why it is that one of my pollen models now lives in Brazil with a man named Green Bamboo. So the main bit of this talk, I kind of vacillated between going for a short and enigmatic title or a very long and explanatory one, and I ended up on the short side. I called it Guardians of Gondwana, and Gondwana, as many of you may know, was the sort of ancient supercontinent that is now comprised lots of what is now southern hemisphere, so Australia, Africa, South America. And Araucaria trees were a huge part of that continent and its geography. So I'm going to start off by introducing you to these trees, which, again, I'm biased, but I think are amazing. And I'm going to zoom in from the genus, this whole group of plants of Araucaria trees, down in particular to Brazil's Araucaria forests and the current situation they find themselves in. I'm going to explain then why it's important we link that out to a much longer history, going back millennia, of humans and climate change and these species. And then I'm going to bring in the work I'm hoping to do that involves the 3D pollen and these indigenous communities who still live in this region, before starting to think, moving from work that I have done, and in many cases it's published, to work that I am doing, and it is in its early stages, to work that I would love to do, and it's still mostly thoughts in my brain and occasional spiels I go on with people who can't escape. And so that's me thinking about these trees, Pug, Pewen, and Bunya. So, to introduce Araucarias, does this look familiar to anybody? Yes. Hans, does it look very familiar to you? This is just out. Yes, so it's over the way from us. So this is a tree called a monkey puzzle tree. Its native name, Mapudungun name from Chile and Argentina is Pewen. It is probably the most familiar Araucaria tree. If you drive around much of English suburbia, you will see some trees that are shaped like this in people's gardens. Okay, they're very common, but they're often planted far too close to places because they have a habit of dropping big branches as they get older, and that's not something you want in an M&S food hall in Sussex. These are very common trees, and they are the closest living relatives to Brazil's Araucaria trees. So this, in the background here, is a family tree, a phylogenetic tree of lots of non-flowering plants. And there's a few things that I want to kind of point out with this, and I'll use the mouse just to demonstrate it. So the length of each branch gives you a clue about the evolutionary age of the different species that are here. So in this group of plants, which are called cycads, you can see there's a lot of species that have got relatively short branches. They're relatively closely related. They evolved relatively recently. It's quite a quick adaptive radiation of plants. What you can see when you look at the group of Araucaria trees is you have very long branches with nothing in between, or very few extant species, still living species in between. And that's why these trees are quite often referred to as living fossils. It's not a term that everybody likes, but there is reason to use it. This is a literal fossil. from 160 million years ago of an Araucaria tree that has lots of similar features to ones you still find in the same kind of region in Argentina, in Brazil. This here is a replica of a fossil of a plant called Wallemia, which was known for several million years, dropped off the fossil record about 2.5 million years ago, and then reappeared in a gorge in Australia in 1990 something. It was found again with huge numbers of similarities. And so this is why these plants are kind of referred to as living fossils. And they grow predominantly in the southern hemisphere in these countries here. And this is Gondwana distribution. Now, Brazil's Araucaria, Araucaria angustifolia, is, as I said, the sister species to Chile and Argentina's monkey puzzle pear tree. But they're separated by 28 million years of independent evolution. I can't really get my head around that length of time. So if you squash that 28 million years down into 24 hours, North and South America don't meet until about 9:30 in the evening. Okay, the first evidence for Homo sapiens comes in at about 9:45. Okay, these trees have been around a lot longer than humanity, which is why what is happening to them is such a tragedy. So this is my son, dressed, I think, for gardening. I'm not sure why he wore all that stuff. This is him when he was a lot younger with my grandparents, his great-grandparents. And no human has ever lived in a world without Araucaria trees. The worrying thing is that we may have reached a situation where my son's generation could be the first to do that. And it's all happened in the lifespan of the people in that photo. So I want to speak a little bit about the state of Brazil's Araucaria forests in the present and in the near future as well. So these are Brazil's Araucaria trees. They're called Paraná pines as well. They're sometimes called pinheiros. They've got a few indigenous names as well. And they produce these huge seeds. I've called them for years, pine nuts on steroids. And when I went to Brazil for the first time early this year, I was very pleased to discover that I was right. They're huge, they're quite tasty, they're incredibly filling, and they're produced in enormous quantities. This was just in a supermarket down the road from the hotel I was in. And they're a delicacy. People really enjoyed them. As do these trees are ecological keystones. They kind of hold the ecosystem together because birds and rodents and other mammals love to eat them. They produce seeds at times of year when very few other things are producing fruits. They're a really important resource for the ecosystem. And they're really valued by people who live there as well. This chart shows you the popularity of different native tree species in the state of Santa Catarina among rural residents. And the one that tops the list is the Araucaria tree, predominantly because it produces this really much loved food. You find Araucaria branches on the the coat of arms, the state of Paraná. Like, they're very, very significant cultural identifiers in southern Brazil. And that's been the case for many thousands of years. So they are absolutely fundamental to indigenous cultures in southern Brazil. So this picture here is a group of Colloquium people. There's also a bigger group called the Kangang and another group called the Guarani. And Araucaria trees are absolutely fundamental in their cultures for all of them, not just because they produce food, but because they're part of their understanding of the world, their cosmovision. So for Kangang people, the way to reach heaven, or one way to reach heaven, is to climb an Araucaria tree. It's metaphorical, it's not a literal, get to the top of the tree and you've made it. But Araucaria trees kind of feature in their marking out of physical space and in their shamanic space. They matter enormously. This is an excerpt from a story that's been published quite rarely for one of these ones. It tells a story of a beautiful Kangang woman who eventually came to fall in love with the old man from a fallen star. He transformed into a handsome warrior. They decided to get married, and they transformed he into an Araucaria tree, she into I think it's called Gralha Azul. It's like a blue jackdaw kind of bird. And what it says is that she, as this blue jackdaw, would travel around collecting the Araucaria seeds and planting them, because every time she planted one of the seeds of her lover, it would grow into an Araucaria tree all the way through the Kangang territory. And that way you would have another Kangang for every Araucaria. This relationship between Kangang people, these indigenous people, and Araucarias is extremely tight. So all of this makes it even more upsetting, I guess, that these trees are critically endangered. They are on the brink of extinction. Now, there's various charts and things I could show, but I'm going to bring back this photo of my grandparents and my son. These are photos I was sent by a colleague in Brazil. This is the city of Chapecó, which I go visit. And as you can see here, this was taken in 1940 when my grandpa here would have been 15, and my grandma would have been the same age as well. I want you to notice two things. I want you to notice this building here, the quite distinctive shape. This is the Cathedral of San Antonio. And I want you to see in the background, you'll see this very big dense forest with quite a lot of these dark T-shaped trees. Those are Araucaria trees. This is Chappaqua today. That forest is gone. The Araucaria trees are gone. 1940 was the beginning of the second and biggest wave of logging of Araucaria trees in Brazil. And from the late 1800s, when they were practically untouched and had been for hundreds of years, they've fallen to this much, much reduced, critically endangered state in about 150 years. So I've done a little bit of research on this, the top right and the bottom left from a paper I recently had published. Depending on how you want to calculate it and how easy you are on including different sorts of forest in, there's native forest in maybe 30 to 40% of the Araucaria forest region. But if you only count forests that is of higher quality, you very rapidly get into single figures of percent of the forest that is left. I was quite surprised when I discovered that another paper had been published in the same issue, the same journal, looking at this question from a slightly different angle. And they said that if you looked only at areas of forest that had a lot of Araucarias left, there was only about 4% still in southern Brazil and Argentina. You can have a look at this map at the top. You'll see there's lots of places that don't have colored circles. Those are places where Araucaria trees should be, but aren't. This species is rapidly disappearing, and climate change is only going to make that worse. So these trees grow in this sort of light green area and the sort of orangey grasslands over here, associated with this climate type that is actually quite similar to the one we have here in our country. It's a bit warmer, but similarly it gets fairly cool, fairly cold, and it's moist all year round. It will rain more or less whenever. But that climate type is going to disappear as this century wears on. And again, something that's been now subject to quite a bit of research. Depends a bit on how you set up your models, but what you find, however you do it, is you get in these pictures, these grey areas, are areas where the trees are no longer going to have climate conditions that suit them by later in this century. This is some work that I did, and you can see that the sort of lighter grey areas, these are areas where there's going to be a loss in climate suitability. If you look very closely, you'll find that there are areas sort of more red and black, especially river valleys where it's going to be sheltered enough to look after them for longer. But when you see the sort of non-coloured areas of this map, those are areas that have lost their natural vegetation. So you've got this combination of human factors and climate change pushing this incredibly valuable tree species towards extinction very quickly over, like I say, the lifespan of the people in this picture. These are very, very valuable trees from an evolutionary standpoint, an ecological standpoint, from a cultural standpoint, but this combination of human actions and climate change is pushing them over the edge. And so that's why it's important to take a bigger view of their history. It's not just about what's happened since 1850, it's also about what's happened over the last 3,000 years, 10,000 years, because these trees have been there for a very long time, and so have people. This is a piece of rock art that was relatively recently discovered. It's quite difficult to see until you see the enhanced version. This is rock art at the moment undated, but probably from the last few thousand years, that people have drawn Araucaria trees and creatures in them, possibly people in them. These trees have been important to indigenous people in southern Brazil for a very long time. These trees have survived millions of years of climate changes, thousands of years of human actions, and understanding how these things have shaped their past can help us manage and look after their future as well. So this is why I've been interested in pollen, because pollen is incredibly durable. It will last for millions of years in the right conditions. So if you can find a bog or a lake that's got lots of mud, there's a chance you'll find pollen stacked up in it over thousands of years, and it will tell you the story of that landscape from deep in the past to the present day. And that's something that we've been doing in southern Brazil with some colleagues from the University of Reading, a university in Chile as well. I'm going to show you. So you might be able to see just here in the middle of this picture, there's the outline of a ring. Sorry, put the mouse in there properly. This is an archaeological site, and there's loads of them in the area. You can see all these blue dots. These are funerary sites, so sort of old cemeteries. This is, I think, a mound enclosure complex. You find these half underground house villages called pit houses. And these belong to the people who were the ancestors of the Kaingang and the Shokman indigenous people. And there's a bit of a debate in the literature about exactly how much climate and people contributed to the past dynamics of these ecosystems. You have quite a lot of people saying, well, the forest expanded when it got wetter or where it got warmer, and therefore that's indicative that climate change made these things happen. You have other people saying, well, there's lots of evidence that humans made this happen. We've just done a study that I need to publish really, that combines a lot of different tools, and I won't get into the details of them. But essentially, we took all these different ways of looking at the question, we brought them all together and used them to shed light on each different part. We did modeling, computer modeling that shows what you would expect to happen if everything were controlled by the climate. We looked at things like charcoal and pollen to tell us about past fire and vegetation dynamics. We brought together, I think it was 40 odd pollen sites that already existed, as well as 3 new ones that were very close to archaeological sites. So we could see what was happening in close proximity to humans. And we did that with a lot of radiocarbon dates that tell you about how old archaeological sites are, how old these pollen grains were. And ultimately, we found, as you might expect, that it's more complicated than headlines tend to suggest. One of the things we found is that Araucaria forest expansions are not as common as is generally made out. Quite often, you see them continuing at very low levels for thousands of years with no great changes. Changes are more the exception. And where they happen and when they happen, it's often where models would predict they should. So you often see these changes happening when it does get wetter and warmer, and that's why that might have contributed to the expansions of the forest. But we also found that climate on its own wasn't enough to explain this. You also need to think about feedbacks between fire and the forest and grassland. So in this landscape, fire will burn the grassland. It won't tend to burn the forest, but it will kill any trees trying to establish in the grassland. That's a fairly stable dynamic, and if there's not much change to the fire dynamics, then it will continue like that for a very long time. What we think happens is when you get this slight increase in rainfall and slightly increased temperatures, it slightly improves the odds of forests being found and slightly decreases the likelihood of fire. But in some places where you have good starting conditions with just the right amount of forest to be near a tipping point, you see this runaway effect where all of a sudden you have slightly more forest and slightly less fire, which allows slightly more forest, which prevents slightly more fire. And all of a sudden you end up with a runaway expansion of Araucaria trees and Araucaria forests. But we also found that although it's not obvious that indigenous people kind of spread all the forests and are responsible for all of this expansion of the forests, we do think we've got good evidence for indigenous communities actually shaping these forests and changing them where they lived among them. So one of the things we find under natural conditions is when you've got a lot of fire, this red line being quite high, you tend to have relatively low amounts of forest and relatively few Araucaria trees. They don't like the fire, and the fire sort of suppresses their growth, suppresses their expansion. So high fire leads to low forest. If you look at the black line here, you can see the same kind of thing. Lots of charcoal over here means relatively low forest, but only when the charcoal drops, you get less fire, you start to see more Araucaria trees, more forest. But we also see when humans were around, so here we can tell that through the presence of maize and beans pollen crops, and here again near an archaeological site where we get this increase in maize, we see a very different pattern. We see relatively high amounts of fire, along with relatively high amounts of Araucaria trees. So if you look at the red lines on this graph here, you can see that in areas with lots of human presence, increased fire is actually associated with increased Araucarias. Now, this is very different to the natural situation and suggests quite a big difference that was being caused by the indigenous people here. And again, we see it accompanied by this big cultivation of maize up here. This is a signal of indigenous people kind of shaping these forests. And in particular, in this site called Amaral, which is very close to a big archaeological site called Baggio. Baggio was occupied for several centuries continuously. And we think we can see the story of its occupation in this paleo record. So in the early days, there's quite a lot of Araucaria trees, not a huge amount of other stuff, not very much cultivation, and a fair amount of fire kind of in the neighborhood. Then when the settlement seems to be founded, we see this dip here, an opening up of the landscape. So an increase in open ground, much more cultivation of maize, a sort of drop off of regional fires, but a lot sort of continuation of local fires. So still a lot of local fire. And we also see this kind of slightly mystifying change in the forest, where Araucaria trees decline, but the forest in general increases. Trees called brachytingas taking up the strain. And so this is suggestive that we can see this development of this indigenous village in the pollen record, in this paleo record. And so we've got this kind of view of this is what we think has happened based on our sort of interpretation of archaeology, of this modeling data, based on our interpretation of the paleo-ecological data, the fossil pollen and the charcoal. This is what we think we have. We have forests expanding for natural reasons, to do with climate, to do with fire, but indigenous people, where they live, are more intensely occupying these forests. They're making quite significant changes to them. They're opening them up with fire, they're growing maize in them, and that seems to be changing their composition. But there's a limit, there's a real limit to how well we can understand this, right? I'm not an indigenous person, I'm a white man from England. Okay, there's a limit to how well I can understand and interpret these indigenous histories. And so what I've been trying to get off the ground is something that I'm calling participatory paleoecology. So paleoecology is the study of this very long-term ecological changes. And generally, it happens in the way I've just described. You have scientists who sit in labs, they will look down microscopes and they will analyze samples they come across. I would love, and I'm planning to go and work with indigenous communities to try and join together our different ways of understanding the past to see if we can get a better, more holistic view of how things have changed over thousands of years. And so I said earlier on I was going to explain why it is that one of my pollen models is in Brazil with a man named Green Bamboo. This man in the blue t-shirt is the vice-cacique, the vice chief of an indigenous community called Tolda Wimbu. I forget exactly what his kind is, but it means green bamboo. And when I was showing them the 3D pollen grains, including that one that you see in the picture, I was explaining how we can use it. So the one similar to the one you put, Bryony, that's a grass pollen grain. One of the challenges with grass pollen is you don't know if you're looking at bamboo or maize or just lawn grass. It all looks very similar. And he went, oh, the green pollen from bamboo, like me. And I doubt that man had thought a huge amount about pollen in his life before then. But it was interesting to have that connection. And I said, well, absolutely, it is very much like your name. Feel free to keep the model. My hope is that 3D pollen is going to play a key role in helping to make these connections with people and past focused research so that we can come up with a better idea of how these places change through time. And this should work in southern Brazil. It's got a better chance of working in southern Brazil than in many places because there's a very clear cultural continuity from what we see in the archaeology to what historians recorded when Europeans first came into contact with these people, even through to what people themselves, the indigenous people, are still doing today. There's a lot of similarities in the customs. Obviously, there are caveats that need to apply here, but you can be fairly clear that the people that lived here 1,000 years ago are very similar to the people who live there now. And so with these caveats, you can understand a bit about the past by understanding the present. But the contemporary indigenous communities have had very little input into research like this. They tend not to have been spoken to. People haven't gone and talked to them about it, asked them what they think. They haven't been able to contribute their views. And as a result, we as a scientific community really know very, very little about how they understand these very long-term environmental changes, even though this information could be really helpful. And so the two things that I'm really keen to try and do are these. One is a thing that is fairly immediate and should be possible in the next year or so. One is a longer term aim that I would love to try and develop over the next few years. The first is what I've been thinking of as knowledge repatriation. This idea that we, the scientific community, me specifically as a Western scientist, we have knowledge about these landscapes, about how they've changed through time, about their relationship with these people's ancestors. It's not right that this knowledge only exists in English language scientific literature, in Western universities, or even just in universities on its own. These people should be able to know this information. They should have it available to them so they can use it if they want. And so one of the things I'm hoping to do is to go and to present this paleo research using things like the pollen models to communities to explain the kind of things that we're looking at, the kind of things we think we found, and then hopefully to set up this second part, which I would be very pleased to do, which is try and move into knowledge co-creation of saying we understand the past in this way, but it's not the only way to understand it. It's a concept called two-eyed seeing, which has come out of North American indigenous scientific relationships. You can see things in two different ways and bring them together holistically. I would love to try and do that in paleoecology. It's an idea that was kind of sparked by this paper here. Now, this is complicated. It's difficult, and I know that several of you in here have got experience of working with communities and workshops. And so some of the things that I did in June when I went to Brazil will be very familiar to you. And I would love to hear more thoughts from you about some of the challenges that I'm going to be facing and some of the things that will help to make this a success. But one of the things that I think is going to help make this a success is this lady who's in most of the photos. Her name is Claudia. She is an academic at a university called Universidade in southern Brazil. And she helps run the Indigenous Teacher Training Program for Western Santa Catarina. And so she and her colleagues will go to these indigenous lands in Brazil, and they'll train the teachers at these indigenous schools. And so I had the opportunity and a huge privilege of going to 3 different indigenous schools in 3 different territories, and just saying hi to people and saying, introducing myself in slightly rough around the edges Portuguese, and explaining what it was I would love to do to meet them. Another side of why Claudia is hugely helpful. This man here in the middle is the regional representative of an organization called FUNAI, which is Brazil's government Indigenous Peoples Agency. And he did his master's with Claudia, so she made an introduction with him. So I spent a very short week, it felt, going around these different places, introducing myself, explaining what it was I hoped to do. And people, by and large, were very welcoming. They said that they'd be delighted to have me back, which was hugely encouraging. But as I'm sure many of you know, community relationships are complicated things. And there's a lot of things that I, as a non-Portuguese speaker, well, as a non-native Portuguese speaker, as a non-Brazilian, non-Indigenous man, there's a lot of limits to what I can do. I wanted to illustrate it with this. So this is the first community I went to, a place called Araucaria, very close to the city of Chapecó. I got to go to a couple of schools in the territory. I met this man here, is the cacique, the chief, his vice-cacique, his vice chief, and this is one of their education classes for learning how to do basket making. These pictures are from, I think, about 2 years ago. When this man was elected cacique, there was disagreement in the community about whether he should have been a cacique or not. And that disagreement ended up in violence that killed someone, ended up with 2 people having attempted murders. 10 houses and 7 cars were burned, and the people who kind of didn't accept his election were removed from the community. That's a huge amount of upheaval and a lot of internal politics that, frankly, I don't understand, that I am not very aware of. So I kind of want to include this as an illustration of some of the challenges that I think I can foresee about working in these communities. Claudia and her colleagues understand them better, but I'm aware that coming in sporadically from afar is going to mean entering situations where there's a lot of uncertainty for me. And I think there's quite a lot of challenges that I'm going to face. It takes a full day and about £1,000 to travel to southern Brazil. And so you can't go very often. I know that you guys many of you work with communities here in Hull. It's an awful lot easier even to get to Grimsby than it is to get to Chapecó. Language, and more than one language. So I've been learning Portuguese for a couple of years. Like I say, I think it's rough around the edges, but it does seem to work. But people in these places, especially older people, many of them actually still speak Kaingang as a language. In Araucaria, that Sarah is speaking about, is actually the first language for people. Children tend not to learn Portuguese until they go to school. And so it's also exceedingly difficult for me to learn Kaingang. There's no educational resources. So there's a limit to how well I can kind of relate with people and how well they are explaining things that they may be thinking of and they may have been told in a language that is different to the one they're explaining it in. And I'm hearing it in a language that I have to translate into my own English. Again, similar to the last slide that I showed you, there's a question of cultural literacy. How well can I understand Kaingang or other indigenous cultures? Are there things that people are going to say that I don't understand that kind of slide past each other? And will I be asking questions from a scientific point of view that simply do not make sense from an indigenous perspective? There's these issues of community dynamics, as I mentioned, and power dynamics. I am, as I've mentioned already, a white Western scientist. I'm a man, and I hold an awful lot more power in the eyes of most of Brazilian society than they do. These people, these communities are very overlooked. And so I'm kind of conscious that this is something I need to navigate. It's a huge question about ethics, working with indigenous people in Brazil, working as a foreign researcher in Brazil, working on natural environment in Brazil. All of these things are complicated. And then even after we've addressed all of these questions, there's a question of how well these people would be able to answer the questions I have. If I sat you down and showed you an archaeological site from 1,000 years ago from East Yorkshire, and said, what do you make of this? I mean, there's a limit to how well you'd be able to kind of explain what you think is going on. And so when I think about these challenges, at times it feels kind of overwhelming. But one of the things that I found really helpful was actually going back and thinking about how the people received me. And it kind of shed a bit of new light on some of these things for me. For example, the power dynamics. They were delighted that they had a white foreign scientist in their midst, because these communities are almost always overlooked. They said that they'd not had a scientist in living memory come and talk to them. It was amazing to have someone. And I kept speaking, I couldn't think of a better phrase for it in Portuguese. I kept talking about giving a stage to Indigenous knowledge. And it was something they were very keen on. You know, the opportunity to kind of incorporate their understanding, their ways of understanding the world into the science, and to give it a hearing to the wider world was something that was very, very well received. And it even helped shed light on some of the things that I didn't really understand. So I've shown you the squiggle graph already. One of the things that is complicated to understand is the separation of black and green lines that happens around the time this village seems to have been formed. We see fewer Araucaria trees. We see this rise in something called Bracatinga, which is a different kind of tree. About the same time, you get this very intense cultivation of maize. And I mentioned this to a couple of the Indigenous people I was speaking to, and I said, well, do you know anything about this tree called Bracatinga? And they said, yes. They had previously said every plant has got a use. They said, yes, we know Bracatinga. And I said, well, I see this. We see this sort of maize and Bracatinga growing together with a bit of fire. Can you shed any light on that for me? And both Duco, the guy who works for Funai, and Green Bamboo, the guy here in blue, said the same thing. They said, well, yeah, if you go to a territory called Mangarinha, which was a few hours further north, they grow maize underneath the canopy of Bracatinga trees. The Bracatinga trees are in the bean family. They kind of nourish the soil with their roots. And when the leaves fall, it's nourishing for the soil. And the maize plants like the shade. To my knowledge, none of that is in the scientific literature. I've never come across a record of that cultivation system in Mangarinha, but it does raise the possibility that these kinds of conversations can do really useful, important things for us as a scientific community, but they could also demonstrate to these Indigenous communities that this is a cultivation system that's got 700 years of history behind it, and is therefore incredibly valuable as a way of navigating the power dynamics and landscapes in Brazil. It could be invaluable. So I'm going to very quickly whiz through this last bit, which kind of, moving from work that I have done to work that I'm doing to work that I would love to do. Thinking about fug, perwen, and bunya. So fug is the Kaingang word for Araucaria. I just called it fag the first time I said it, and I was very quickly corrected by a Kaingang teacher. Perwen is the Mapunungun, the indigenous word in Chile for the monkey puzzle tree, and bunya is an Araucaria tree that grows in Australia. There are lots of similarities. They're very closely related. I haven't got time to go through all of them, but they all produce huge cones. In the case of bunya cones about this big, they can kill. Huge cones with big seeds that are very nutritious. They're charismatic trees. They're important in the ecosystem. They've been valuable to indigenous people for many thousands of years. They're all in some level of danger. So Araucaria trees in Brazil are critically endangered. They're on the brink of extinction after the logging they've suffered. Monkey puzzle trees, perwen, are endangered. They also have suffered a lot of logging, although that was kind of stopped relatively early. Bunya trees benefited from some of the first environmental protections in Australia. People started cutting them down, but then it was quite quickly stopped. And at the moment, they're assessed as least concern. But they've all got problems incoming from climate change. They all like relatively cool, relatively moist conditions. They all grow on hilltops or mountains. And they've got different sort of extensions of their range. Brazil's one has got quite a big range, in which it's now very scattered. The monkey puzzle grows on mountain slopes, so it's got scope to move up the mountains in response to climate change, but it's got quite a small range and population. There's all these differences and all these similarities, and they're all incredibly valuable to the indigenous communities that live there. So in Chile, there's a group of people, an offshoot, I think, of Mapuche community called the Pehuenche. Che means people, perwen means Araucaria tree. These are literally the people of the perwen, the people of the Araucaria tree. In Kaingang, people, they sort of treat the Araucaria trees as part of their community. These are part of their society. And in Australia, the Bunya Mountains, won't try and say the name for it in one of the languages, but it means sort of mother's breast, mother's milk. Okay, this is hugely important. People used to come in Australia from all across the region. They travel for weeks, for months to go and attend these festivals. These trees are hugely important to Indigenous people. And so what I'd love to do is try and do some transcontinental knowledge exchange. Now, I started off talking about knowledge exchange as a way of helping scientists talk to normal people. In this case, I'd be fascinated to try Indigenous to Indigenous knowledge exchange. Because, for example, the discourse on fire use by Indigenous people is much more developed in Australia than it is, to my knowledge, in Brazil or Chile. But then you have very different Indigenous land rights situation. You get very delimited lands in Brazil. You don't get that in the other countries. I would love to try and connect these different communities together with videos and perhaps even in person to get them to see the landscapes that will look quite familiar to each other. So they can exchange information. They can talk about how they use their Araucaria seeds, how they look after their trees, so they can talk about their cultural histories, their responses to colonisation. As a scientist, I'd also be really interested to talk to them about the impact of climate change on these trees they value so much, so that we can start to have these conversations about how the humans, not just Indigenous peoples, but the rest of society, can look after these trees in these very damaged cultural landscapes. And then we can also go back and try and understand their very long-term past and history in the same kind of way. Now, as I say, this is just stuff I'm thinking about. I'm hoping to put a funding proposal together on. But to wrap up, going back to this Gondwana thinking, this sort of southern hemisphere across continental phenomenon is why Araucaria trees grow where they do. You see them being very important to Indigenous people for thousands of years, and you see them all imperiled for the future. I would love not just to look at these things through a scientific lens, but also to try and bring in Indigenous people's views and community perspectives as well. So I'm going to stop waffling there. Thank you very much for listening.